Okay, I want to have a look at a problem now where we need to do some interpolation. We're asked to find the height of tide at Ullapool on the 5th of January 1355. Well, Ullapool again is a standard port, so we go to the values for Ullapool, standard port, and we want the 5th of January, we want the height at 1355. So we go to the 5th of January and we can see that the height falls between 1055 and 1713. Our time is 1355, which falls between those two times. So we write down the 1055, 1713 times and the two values of high water and low water. And that is what we need to take off this table here. And we finish using that now. Now we've got those values and we've written them down there. We don't need to look at that anymore. So we've written down the times of high water and low water and the heights. We subtract one from the other and that gives us our range. So our range is 3.8. From the Ullapool graph we can see that the ranges, the spring range is 4.5 and the neap range is 1.8. Our range of 3.8 falls between these two. Okay, so what we need to understand now is that when we do our plotting, we're going to have to take the values off the spring curve and the neap curve and interpolate. But first of all, you plot the times of high water and low water. Low water is 1.1, high water is 4.9. 1.1, 4.9. We put those two in, low water and high water, and draw our tide line between the two. That's the first thing you put on. Okay? Now, we need to find the time of the height of tide at 1355. High water is 1055, so you always put in the high water time just straight here where it says HW, 1055. 1355 is after 1055, so 11, 12, 1355. So that is the 1355 mark. Had they asked for a time at 12:30 or 11:30, you would have simply worked between these values. And don't forget, each block there, each little amount is 10 minutes. Anyway, we're at 1355, so we go straight up the 1355 line, and I've indicated it with arrows. And then where we hit the neap curve, we go across to our tide line. So from the neap curve we go straight up to our tide line and then straight up to get a value, and we get 3.0 for that. And then again we go straight up to the spring curve, go straight across to the tide line, vertically up, and that gives us a value of 3.4 for springs. So had our range between these two times been 4.5, we would have simply used the spring amount. Had the range been 1.8 between these two, we'd have used the neap's amount. It's between the two, so we need to interpolate. So we've written down the two values we've taken off here, 3 and 3.4. 3 and 3.4. So we dispense with the graph now, because we're going to do the interpolation on our answer script. From the tables originally we had 4.9 and 1.1, which is a range of 3.8. From the graph, the two mean ranges, 4.5 and 1.8, gave us a range of 2.7. So the 4.5 and 1.8 from here, we wrote here, and that gives us a range of 2.7. By plotting, springs gave us 3.4 and neaps 3. So the difference is 0.4. So the range falls between 4.5 and 1.8. The 3.8 falls between those two. So we need to interpolate. So we can say that the range is 3.8. Let's go to the 4.5. So 4.5 minus the 3.8 divided by our range of 2.7. Now the reason we do that, our 3.8 is nearer to 4.5 than 1.8. So we can just simply deduct 4.5 from 3.8. You could have gone to 1.8. You could have gone 3.8 minus 1.8 over the 2.7. But I've gone 4.5 minus the 3.8 over the 2.7 there. So we're coming down from the 4.5 towards the 1.8. So that is 0.7 over 2.7. We now multiply that by the difference between the two that we picked on the chart, because we need to find this difference to apply to get our correct answer. The difference is 0.4, so therefore it's 0.7 over the 2.7, 2.7 is from here, the range, 0.7 over the 2.7, multiplied by our difference of 0.4, and that gives us 0.1. So the value will be 3.4 minus that 0.1, which will give us 3.3. Okay, now the value must be between 3 and 3.4. So our answer here, the height of tide at Ullapool, the height of tide is 3.3. Now don't forget, if you're looking at your chart, you would add that to the chart datum value to get the actual height of the water from sea level. But we're asking for the height of tide, and it's simply 3.3. So let's just quickly look back again. Because our range initially was 3.8, it fell between these two values. So we had to interpolate between the two. And that's why we've taken the value from the tables, 4.9 and 1.1, the mean ranges from the graph, 4.5 and 1.8, and our plotting values, and we've simply interpolated to get the correct value. And that was calculating the height of tide. Were we asked to calculate a time at a certain height, we would simply have gone down from a height up here across to the curve, and we'd have ended up with 2 times, and we'd have simply interpolated between the 2 times, just like we've interpolated between the 2 heights. So that's how you would solve a problem by interpolation.